The last thing that we're going to talk about with the relationship between the unit circle and the real numbers is something that I was kind of already playing with when we first introduced the concept. We talked about how for each real number, there needs to be a corresponding xy point on the circle, where after we've traveled a distance of t, that is our stopping point. But the way I started the conversation was a little bit different. Instead of talking about that distance on the outside, I instead talked about the central angle theta. These correspond to one another as well. In this case, the real number t, this distance that we want to travel, is going to have a central angle whose radian measure is also t. Because we're dealing with a unit circle, therefore a radius of 1, we see this exactly as we saw in the earlier sections in this chapter. We can associate the distance traveled around the circle exactly to the radian measure. That's, again, one of the big benefits of radian measure instead of degree measure. We've seen this before, but we have this idea here from our arc length formula. The length of the arc is equal to the radius times the central angle theta. Because it's a unit circle, the radius is 1, so our arc length is exactly equal to our central angle. We set the arc length by choosing a real number t, and that, therefore, also determines the arc length. Again, this is one of the nice parts about radian measure. Everything seems to just click together. And if you're on a unit circle, all the better. Because now you don't even have to worry about the length of the radius. Your arc length and your central angle are 1 to 1. Now I want to go ahead and talk about one of the things that I addressed at the end of the previous video. One of the things I mentioned is that we've essentially created a function here, where t is the input, and we have some corresponding point xy that's the output. There's a little bit of an issue here, though. As a general rule, when we deal with functions, we expect a single input to get a single output. Now, that's not all that bad. I mean, the point xy is technically a single output. But the problem is that we're going from a single value to an ordered pair. So that's where we're going to see a little bit of a division happen. What if we could create functions where t was the input, and you actually had two separate outputs? In one case, you put t into a function, and you get the x-coordinate for the point on the circle where you stopped. And in a different function, you place t in as your input, and you get the y-coordinate of the point where you would stop. That gives us the basis for our first few of the trigonometric functions, which is where we're going to go ahead and go now. In total, there are 6 trigonometric functions. Remember that for lecture 3, we're only going to be dealing with the first 2. So again, we've seen this here, and this is kind of the lead into the idea of the trigonometric functions, but our coordinates for the point where we stop on the circle, x and y, can both be written as functions of this real number input t. You pick an angle or you pick a length, and I'll tell you the xy position where you stop. Except x and y will have to be handled by 2 separate functions. Now, these different coordinates, x, y, actually have a series of variations. There are some functions that refer to just x and y individually, some refer to their reciprocals, and others refer to a ratio of the x, y values themselves. So we're going to be taking it slowly here as we build up. These 6 trigonometric functions that we're going to be taking a look at are sine, cosecant, cosine, secant, and tangent, cotangent. While you've probably seen or heard of these before, our goal in this class is going to be to explain exactly where they come from and how we should best interpret them. One thing to note is you're not going to see these words on most calculators or in any program that's going to talk about trigonometric functions. They are instead abbreviated: SIN for sine, CSC for cosecant, COS for cosine, SEC for secant, TAN for tangent, and COT for cotangent. Out of these 6, the 2 that we're going to work on today are going to be sine and cosine. These are the 2 functions that directly correspond with our x, y values in the point. But as for the 4 remaining ones, we're going to talk briefly about how they are defined as well, so I can kind of loop things together with what I stated earlier. Here is the defining piece for this particular section. This is the part of trig that you need to understand. It's not the part that you'll necessarily do when it comes to homework, but this is the connection that you have to make. Let t be some real number that corresponds with a central angle or corresponds with a length that we're traveling around our unit circle. Then xy is the point on the unit circle that corresponds to t. It's after you've traveled t distance, or after you have an angle that opens up with t radians, xy is the point where you stop. Then sine of t is going to be equal to y. Here we have y shown as a function of t. As we said on the previous slide, now it's actually shown to us. If you ask for the sine of a given angle, or the sine of any real number, y is the y-coordinate for the point that corresponds with it. Similarly, cosine of t refers to the x-coordinate. The other four remaining functions are kind of shown here. Cosecant is the reciprocal for our sine value. So we take the y-coordinate from our point, but we write it as 1 over that y value instead. Because we're writing it like this, we do have the caveat that y cannot be equal to 0. This particular function is sometimes undefined. Think about when you are in the initial position, when your real number is 0. At that point, the xy point is 1, 0. Y is 0, so cosecant would actually be undefined in that case. We have the same thing for secant here. It's the reciprocal of the cosine function. So in this case, it's written as 1 over x, and again with the caveat that x cannot be equal to 0. As for tangent and cotangent, these are the two that I refer to as quotients or ratios of the xy coordinates themselves. Tangent is written as the y-coordinate over the x-coordinate with the caveat that x cannot be equal to 0. And cotangent is written as x over y, where y cannot be equal to 0. One thing to kind of note here, and this has become a connection to later material as well, here, tangent being a y over an x might make you start thinking about the idea of slope to a certain extent. This idea of y's over x's. Another connection that I want you to make here is that while the cotangent is a ratio of x and y, it is also the reciprocal of the tangent function. So in this particular case, y over x, its reciprocal would give you x over y. There's lots of different connections between the various trigonometric functions. Sometimes tangent is even referred to as sine of t over cosine of t, since those are equivalent to y and x respectively. Okay, so that is the basic idea of how the different trig functions fit with this idea of a point. Now let's start to go ahead and dig a little bit deeper. One thing to note here is something that I kind of included as part of my explanation here. We talked about that there are certain cases where the functions may be undefined. Cosine and sine don't really have that issue. We never had to put a caveat that says, well, x can't be 0 or y can't be 0. But the other four remaining trig functions did have that requirement. So tangent and secant are undefined whenever x equals 0. Let's give as an example here, t being equal to pi over 2. That goes a quarter turn around the circle, so it has the xy point 0, 1 corresponding. In this case, if our x-coordinate is 0, tangent and secant are both undefined. So this is actually written as you see here. Tangent of pi over 2 and secant of pi over 2 are both undefined. This would also happen, for example, at 3 pi over 2. In that case, again, x is 0, so these would cease to work. When we're dealing with cotangent and cosecant, they're undefined if y is equal to 0. This is the example that I gave on the previous slide, also stated here explicitly. If t is 0, that puts you in the starting position. So the corresponding xy point is 1, 0. In which case, your y-coordinate is 0. Both cotangent and cosecant fail. They are undefined. This is a small side note before I close out this particular portion of the video. One thing you'll notice a lot of textbooks do is when they're writing their angles as arguments for the trigonometric functions, in some cases they leave off parentheses. So make sure you understand that this symbol that's written here, COT with a 0 following it, 0 is the argument. It's the real number that is being placed into the cotangent function. This is a bit of a personal pet peeve. Whenever you see me write these things, I will always be putting parentheses around my argument so you know exactly what is being used as the input for a particular function.